What is kinetic energy? Kinetic energy is the energy in motion. Any object that has motion has kinetic energy. As well, we have to wonder, what is a chemical reaction? In a chemical equation, there are essentially two parts. There are the reactants, which are the atoms and molecules that interact with each other. Then there are the products, which, as you can tell by the name, are the parts of the equations that hold the atoms and molecules produce. The whole problem together is a chemical reaction. And a couple of examples of chemical changes. There's nail or bike rusting, firework, baking a cake, or the burning of wood. All these reactions involve the creation of new products, and it's important to distinguish them from a physical change where a new substance is not created. With physical changes, we get examples like broken glass or frozen water. So there are a couple of factors that affect the rate of a chemical reaction. Chemical reactions have different rates, meaning they have varying periods of time that the reaction can occur. The rate of the reaction is the speed at which the reaction happens. So, for example, we have carbonization. This is when plants or animals become fossils. This reaction takes hundreds or maybe even thousands of years. Therefore, this reaction has a low rate. The molecules combine at a slower speed than, let's say, a fireworks show. So there's a theory about reaction rates called collision theory. The collision theory says that as more collisions in a system occur, there will be more combinations of molecules bouncing into each other. If you have more possible combinations, there is a higher chance that the molecules will complete the reaction. The reaction will happen faster, which means the rate of the reaction will increase. That's wordy, but the bare skeleton of collision theory is that effective collisions between reactant molecules must occur in order for the reaction to occur. So we have an example of soda and honey. The molecules in honey move slower than those in soda, despite them both being liquids. That is because there is a lower number of collisions in honey. So with all that backdrop, there are several different factors that affect the rate of chemical reactions. The first being temperature. With temperature, when you raise the temperature of a system, the molecules bounce around a lot more. They have more energy. When they bounce around more, they're more likely to collide. That fact means they are also more likely to combine. When you lower the temperature, the molecules are slower and collide less. The temperature drop lowers the rate of the reaction. Another example is concentration. If there's more of a substance in a system, there's a greater chance that molecules will collide and speed up the rate of the reaction. If there is less of something, there will be fewer collisions and the reaction will happen at a slower speed. With surface area, it's nice to have an example. A reaction takes place on the surface of a substance. By increasing the surface area of a substance, you should thereby increase the quantity of the substance that is available to react. This can lead to a faster reaction rate. For example, with the Scooby-Doo gang, Fred would consistently split up the group of 5 to search for clues. 5 people could search more ground at one time separately than together. This makes the rate of finding clues faster. The next thing that affects reaction rate is a catalyst. A catalyst is a substance that increases the rate of the reaction, but is not consumed in the reaction. It does so by lowering the activation energy, the energy level that must be overcome by the reactants in a chemical reaction in order for the reaction to occur. Enthalpy of a reaction, or energy change, is the amount of energy or heat absorbed in a reaction. So there are 2 basic types of reactions, exothermic and endothermic. Exothermic reaction releases heat and causes the temperature around it to rise. In an exothermic reaction, in which a change in enthalpy between the products and reactants is negative, there must be an output of energy in order to start the reaction. Endothermic reactions absorb heat and cool their surroundings. In an endothermic reaction, the change in enthalpy between the products and reactants is positive. There must be an extra input of energy above the energy level of the products in order for a reaction to occur. If the energy, as far as enthalpy is required, the DH is the amount of energy or heat absorbed. If the DH is positive, and energy is if the energy is required, DH is positive, and if the energy is released, the DH is negative. So that goes into enthalpy. So exothermic releases heat, endothermic absorbs heat. Pressure, when you increase the pressure, the molecules have less space in which they can move. That greater density of molecules increases the number of collisions. When you decrease the pressure, molecules don't hit each other as often and the rate of the reaction decreases. Pressure is related to concentration and volume. By decreasing the volume available to the molecules of gas, you're increasing the concentration of molecules in a specific space. Generally, that only works for gases. We don't speak too much about solids and liquids when that goes into part. This is the reaction graph. So just showing the reactants and the products. Previously, we showed you a graph similar to this, only with a catalyst, so how a catalyst affects and decreases the rate of a reaction. Going forward, we are going to be in Unit 3.12, what is meant by forward and reverse reactions. In a situation where a reaction occurs and the created substance is reversible, the forward reaction is a reaction that occurred in order to create that substance, and the reverse reaction is where the substance breaks apart. Equilibrium occurs when the rate of the reaction is the same for both the forward and the reverse. What seems that equilibrium stops the reaction on a macro level, it doesn't. Actually, there are just simply no net changes in the reactant or products of the chemical equation that occurred. Concentration is the amount of products and reactants in a reaction, usually measured in moles. The rates of chemical reactions are reported in terms of concentrations of reactants and products. Depending on the concentration of the reactant, the forward and reverse reactions will overtake each other until equilibrium is achieved. So equilibrium is a state of dynamic equality between the forward and reverse reactions. On a molecular level, equilibrium is a state of dynamic balance in which the reaction rate of the forward reaction and the reaction rate of the reverse reaction are equal. The reaction is still occurring despite the fact that it appears to stop on a macro level. To put it simply, equilibrium is a phase of reaction where no net change occurs for the reactants or the products. So on to 3.25. I'm going to show you the graph first. This is the solubility graph. Solubility graph is a graph drawn to display the solubility of different solutes at different temperatures. Solubility is a graph drawn to display the solubility of different solutes at different temperatures. It determines whether a substance is supersaturated, saturated, or unsaturated. The degree of saturation and relevance to the temperature being expressed in the solution all depends on what the solution is. For example, NH3, being a gas at room temperature, will have different tendencies and properties than NaCl because it is a solid at room temperature. As far as solubility, solubility is a chemical property referring to the ability for a given substance, solute, to dissolve in a solvent. It is measured in terms of the maximum amount of solute dissolved in a solvent at equilibrium. The result from that is called a saturated solution. To read a solubility graph, just find the line for the substance. The amount that dissolves at a given temperature is on the y-axis. So that's moving on from the solubility graph. We're going to find out what is a solute and what is a solvent. Both a solute and a solvent make up a solution. A solution is a homogeneous mixture composed of two or more substances. A solvent is a liquid or gas that dissolves the solid, liquid, or gaseous solute. The most common solvent that exists in everyday life is H2O or water. So what causes a material to become insoluble? Depending on the type of material, the solubility may increase or decrease at temperature. This affects all states of matter. For condensed states like liquids and solids, factors like pressure are less effective. Precipitates can form when two soluble salts react in a solution to form one or more insoluble products. The insoluble product separates from the liquid and is called a precipitate. Precipitates can also form when the temperature of a solution is lowered. The lower temperature reduces the solubility of a salt, resulting in its precipitation as a solid. The solubility of a material is dependent on polarity and temperature. I'm just showing the decreased solubility there. So if the solubility of a material is dependent on polarity and temperature. So some, however, like gases, can be influenced by pressure. The solution process can be divided into 3 steps. There's the solute molecules that separate, the solvent molecules that separate, or the solute molecules separate, the solvent molecules separate, or the solute and solvent molecules attract. See, we both made a mistake. Overall, the process is endothermic. Energy is needed for the first 2 steps. However, the mixing of the last step is exothermic as it lowers the energy. You can identify substances by matching their physical properties with known substances. Identifiable traits can be odor, taste, malleability, hardness, color, state at room temperature, and melting boiling point. Solubility is a trait, as only some substances have the ability to be soluble in a certain solvent.